All right, sixth graders. Well, we are continuing right along here in chapter 7, trying to keep up with our videos here. This is lesson 7.3, and we're going to be focusing on, first off, finding the area of the trapezoid. A trapezoid is a type of quadrilateral that has exactly one pair of parallel sides. And it's not a parallelogram that has two sets, or a square or a rectangle that has two sets. A trapezoid has exactly one set of parallel sides. And for example, here is a trapezoid where this line here and this line here, of course, we're going to use our imagination that all of our lines here are perfectly straight. Okay, so we're just going to kind of imagine that. But this line here that's 10 inches, this line here that's 6 inches are parallel. So areas of trapezoids. Here's the formula. 1/2 the height multiplied by base 1 plus base 2. Well, what does that mean? Well, the base 1 and the base 2 are the two sides that are parallel. So it's not, sometimes it might be the left and the right, and other ones it might be the top and the bottom. So if I fill in the formula, it's 1/2 times my height, which is 7, times base 1 plus base 2. Now, 10 plus 6 is 16. It's the two parallel sides, so times 16. All right, and since I have half, the easiest thing to do will be to cut this in half. So I want to show this formula again. Area equals 1/2 the height, so I plugged in 1/2. The height is 7, okay? And some of you might say, well, the height is 10. That's the tallest one. That's how tall it is. Some of you might think, well, that's what it should be. I want to point something very important out. This base 1 plus base 2. These are the lengths of the two sides that are parallel. The other figure that they give you will be the height, okay? So when I look at this particular trapezoid, this has to be my base 1 and base 2 because these are the parallel sides. This straight side that goes with it is going to be my height. Now sometimes they might give you this dimension just to try to confuse you. This dimension, has no bearing on the area whatsoever. So we have 1/2 times our height times the base 1 plus base 2 put together. 10 plus 6 is 16. So it's 1/2 times 7 times 16. Well, we know that in multiplication, it doesn't matter what order you multiply the numbers. If this is all multiplication, it doesn't matter what order I put them in. As long as I do it correctly, I'm going to get the right answer. So I look for things that I can easily put together. Sixth graders, you want to make the math as simple as possible. So I'm thinking, well, half of 16 is pretty easy. Half of 16 is 8. So 1/2 times 16 is 8. I can eliminate the 1/2. I can eliminate the 16, and I can make this whole thing 7 times 8. Well, 7 times 8 is pretty straightforward. 7 times 8 is 56. So, as always, our area is about carpet. How much does it take to cover? Okay, it's always in square units. For number 1 here, it's going to be 56 inches squared. When I go to this one, 1/2 the base, or 1/2 the height, times base 1 plus base 2. Well, 1/2 times my height. Now this is going to be my two bases because it's the top and the bottom that are parallel. In number 1, it was the left and the right that were parallel. In number 2, it's the bottom and the top that are parallel. So my height is 8, so 1/2 times 8. And then I just need to come over here and I have to figure out what the base 1 plus base 2 is. Sometimes there's a little scratch work. In number 1, it was just 10 plus 6 is 16. This is not as straightforward with the 5.8 plus the 2.7. 8 plus 7 is 15. Put the 5 down, drop the decimal, carry the 1. 1 plus 5 is 6, plus 8 is, sorry, 1 plus 5 is 6, plus 2 is 8, 8.5. So 1/2 times 8 and 5/10. Well, I know that half of 8 is 4. 1/2 times 8 is going to be 4. So that leaves me with 4 times 8.5. So if I just come over here and do 8.5 times 4, I know the decimals don't have to be lined up. 4 times 5 is 20. Put the 0 down, carry the 2. 4 times 8 is 32, plus 2 is 34. One digit comes after the decimal in the problem, so one digit comes after the decimal in the answer. My final answer is 34 square feet. All right? Sometimes they don't actually give you a picture. Sometimes they just give you the measurements. They tell you the height, they tell you base 1 plus base 2. Now, of course, I don't want to forget my formula, 1/2 the height times base 1 plus base 2. Well, once again, 1/2 the height, that's going to be pretty basic. If the height is 12, half of that is going to be 6. Now, I'm going to take that 6 and I'm going to multiply it by base 1 plus base 2. Well, 7 plus 6 is 13. So that gives me 6 times 13. That's not a hard multiplication problem. Might be a little scratch work, but 6 times 3 is 18. Put the 8 down, carry the 1. 6 times 1 is 6, plus 1 is 7. My final answer, 78 square inches. All right, now let's move on to something a little bit different. One of the things we're also going to be looking at in here in 7.3 is composite figures. Now, a composite figure is essentially a figure like this that's made up of different figures. There's multiple figures turned into one figure. Now, if I look at this particular figure, I can see from the division here, well, I have a trapezoid up here. I also have a trapezoid right here, a quadrilateral with one set of parallel sides. So really what I have is I have a trapezoid here and then a little different one right here. All right, so I'm thinking, well, okay. I remember my formula, area equals 1/2 the height, base 1 plus base 2. So if I look at my top trapezoid here, I see that the height is 6 because it gives me this dimension from here to here. It tells me right here is 6. Well, half of 6 is 3. So I'm going to make a note of that. And if I look at my base 1 plus base 2, I have 14 and 9. Well, 14 plus 9 is 23. So this is going to become 3 times 23. Well, I'm going to do a little scratch work here. 23 times 3. 3 times 3 is 9. 3 times 2 is 6. So my top trapezoid is 69. Now, this bottom one, this is something a little bit different because it doesn't give me a height from here to here. It does not give me that. It tells me that from here to here is 6, and it tells me that from here to here is 13. So I have to do a little figuring. It doesn't always give you every exact dimension, 6th grade. Sometimes you're going to have to think and use the information that it gives you to figure it out. So if here to here is 6, and I know that from here all the way down to here is 13, to figure out the difference, to figure out what it is from here to here, the difference, remember that's the answer to a subtraction problem, I'm going to have to do 13, taking away the 6 from here to here. Well, 13 minus 6 is 7. So if I have 1/2 times the height, which is 7, I should have put a 7 there. That's not as easy to figure out. And then base 1 plus base 2, these are my two parallel sides. Once again, it's 9 plus 14. 9 plus 14 is 23. So I just kind of have that. Now I have some different things that I could do. Okay, I should know that 1/2, if I'm doing 1 divided by 2, if I think about that fraction, I know that 2 can't go into 1, but 2 can go into 1.0. Remember, I pretend that's 10. Bring my decimal straight up. 2 can go into 10 5 times, and I know there's none left over because 2 times 5 is 10. So instead of the 1/2, I can pretend that this is 0.5. So that's one possibility. And then, so I'm going to go ahead with that. 0.5 times 7. 0.5 times 7, well, I know that 5 times 7 is 35. And if one digit needs to come after the decimal in my answer, because one digit came after the decimal in my problem, this 5, it's really 3.5. Well, I can do 3.5 times 23. 3 times 5 is 15. Put the 5 down, carry the 1. 3 times 3 is 9, plus 1 is 10. Put the 0 down so everything lines up with my 2. 2 times 5 is 10. Put the 0 down, carry the 1. 2 times 3 is 6, plus 1 is 7. Okay. 105 plus 700, 5 and 0 is 5. 0 and 0 is 0. 1 plus 7 is 8. There's one digit, the 5, that comes after the decimal in the problem. So I have one digit that needs to come after the decimal in my answer. I get 80.5 or 80 and 5/10. Well, that's just the bottom one. When you have a composite figure, you have to find the area of every smaller figure within it and then add it together. Now remember, we found the area of this smaller figure to be 69, and we found the area of this larger figure to be 80.5. So I'm going to have to actually add those two numbers together. 80 and 5/10 plus 69. Remember, I can make that 69, 69.0, because decimals always have to be lined up. 5 plus 0 is 5. Drop the decimal straight down. 0 plus 9 is 9. 8 plus 6 is 14. I get 149 and 5/10. And so my final answer is 149 and 5/10 meters squared. And that is my final answer. All right, well, we got one more to look at. And here's an interesting composite figure. All right, so if I look at this carefully, I see that if I kind of divide this right here, that I have a trapezoid here at the bottom, and then I have a rectangle at the top. Okay? Now, we haven't done this year, but you should be aware from past years, or at least in 5th grade, that to find the area of a rectangle is length times width, how long it is times how wide it is, which means this rectangle right here, since is going to be 6 times 7. How long it is times how wide it is, or however you want to think about it. Well, 6 times 7 is 42, so I'm just going to make a note of that and put that in there. The real effort is going to come in my trapezoid, because I have a trapezoid here that, of course, I want to remember area equals 1/2 the height times base 1 plus base 2. Okay, well, if I look at base 1 plus base 2, that's going to be 10, and this length here, well, if this is 6, this has to be 6. So 10 plus 6 is 16. That's my base 1 plus base 2. Times 1/2. Now I should know that 1/2 of 16 is 8. Okay, dividing something by 1/2, or multiplying something by 1/2, is the same as dividing it by 2, as we've talked about before, what you know about reciprocals. Timesing 1/2 is the same as making the multiplication a division, and then making the reciprocal. okay? Or you can kind of think of it, we usually start with the division, but it's the same idea. If you want to make it multiplication, you change the sign, flip the number. It's the same idea. All right, now, to figure out the height's going to be interesting because I know the height from here to here is 7, but it doesn't give me this height here. So once again, you're going to have to look at the information that they give you to solve. All right, so from here to here is 7, but it tells me that from here to here is 9. So once again, I'm finding the difference, which means I'm subtracting 9 minus 7. Okay, 9 minus 7 is 2. That tells me that if from here to here is 7, from here to here has to be 2, because 7 and 2 make 9, and it's 9 this whole thing. So it's going to tell me that it's 1/2 with my height of 2. Base 1 plus base 2 is 16. All right, well, so I'm going to go, well, if half of 16 is 8, so that becomes 8. And then 8 times 2, well, 8 times 2 is 16, which tells me that the area of this trapezoid is 16 square feet. But I'm trying to find the area of the entire composite figure, which is the 42 from the rectangle plus the 16 from the trapezoid. If I come over here, 42 plus 16, 2 plus 6 is 8, 4 plus 1 is 5, 58 square feet. All right, we'll talk to you later. Bye.